Alright, tonight we're going to be talking about the trapezoidal rule, and so today we did a bunch of rectangles, and tonight we're going to talk about how do you instead do a little bit better. So we're trying to get better and better approximations, and if you notice with our rectangles we tried the midpoint. That seemed to be the best one, but now we're going to try doing trapezoids. And so if I have a curve that looks something like that, and I could create rectangles, but possibly a better idea would be, what if I created a bunch of trapezoids? And so that might be a better representation of my curve. And so depending on how many trapezoids, similar to your rectangles, the smaller the trapezoids, or the width of the trapezoids, as they get closer and closer and closer, the width gets smaller and smaller and smaller, the better the approximation is going to be. And so let f be continuous on the interval from a to b. So here's our a, here's our b. With n subintervals, that means the number of trapezoids of equal width. Then the trapezoidal rule for approximating, and so now we're introducing a new idea that I haven't talked about yet. And this is the idea of finding the area underneath the curve. And so we're talking about a comes from the interval here, this a right there, and b comes from the interval from right here. So we're talking about a starting point and an ending point. And then we have this thing called the integrand. And what that means is the sum of the areas. So we're trying to find this. It actually looks like an S, and that's intentional. It comes from sum. So we're talking about the sum of the areas. And so we want to know, what is the sum of the areas of each of our trapezoids? And I gave you 3 of them. Okay? And so we're trying to find, what is the total sum of our trapezoids? So they give us a formula, and that would be, the formula is b minus a over 2n of the first height plus twice the second height plus twice the third height, all the way to the second to the last height, plus finally the last height. So let's talk about where they come from. If you notice, my first height and my last height are only used once. If you want to look at it, here is B1, here is B2. And so if I was going to take the area of the trapezoid, then B will be the average of B1 plus B2, and then I'm going to use green right here to represent the height. So the height's going to be green. So the area of my first trapezoid, so it's 1/2 times B1 plus B2 times my height, which is my H. Well, if you notice, if I go to my next trapezoid, I'm using this height again. I'm using this height twice. That's where that 2 times comes from. And so that becomes my B1. This down here now becomes my B2. So I need to find the average of my 2 bases and then multiply that by my height. That's the area of a trapezoid. And then I go and I move on to my third trapezoid. And once again, you'll notice I use that one base again. So I have B1, this becomes my new B1, this is my B2. So if I take the average of this new trapezoid, of the bases for that new trapezoid, and multiply it by the height, that will give me the area of my final trapezoid. So if you notice, the endpoints for your bases are only being used once, and all the interior are being used twice. And so that's where this idea came from, where you're doubling the interior bases. Okay, so just to let you know, we use a trapezoidal rule when our functions are very, very difficult or near impossible to find the area under the curve. And this process that we're talking about, finding the area under the curve, that part of the geometry, we call integration. Alright, we're going to use the trapezoidal rule to approximate the area under the curve, or the sum of all the trapezoids going from 0 to 2. So my A is 0, that's my beginning, and I'm going to 2, that's my end, and I'm using the function x to the third dx, and for n is equal to 4, so that means I'm using 4 trapezoids. So let's kind of get an idea so we can get our x and y coordinates. So I'm going to do x And then f of x is equal to x to the third. And in red, if you notice above, I just kind of copied the formula that's above your paper. And so my first step is I want to find both the x and y coordinates. So I'm starting off with 0. And then, so if I plug in 0 into x to the third, I'm going to get 0. Well, since if I just go up by ones, I'm only going to get 2 trapezoids. I want 4 trapezoids, meaning I need to take 0 or 2 minus 0, which is 2, and then divide that by 4. So the height of each trapezoid is going to be a half. So that gives me the next step up. I'm going to add 0 to 0. I'm going to add a half. And then my next step up gets me to 1, and then I have 3 halves, and finally I end at 2. And so these are the other x coordinates that I'm going to be plugging in. And so if I plug in a half and I cube it, I'm going to get 1/8. If I cube 1, I get 1. If I cube 3 halves, I'm going to get 27/4. If I cube 2, I get 8. And so, unlike a little bit different, so because we've been used to talking about height and width, instead these guys are the heights of the trapezoids. These guys are the height of the trapezoids. And so my height is consistent per trapezoid. So my height is always going to be a half. So when I talk about my bases, my B1, my averaging of my bases, my B1 plus B2, this right here is my first y coordinate, which is 0. My f of x of 1, that means my second y coordinate. That's this guy right here, 1/8, and so forth. So essentially for all the middle ones, all the y coordinates that are in the middle, we are doubling. That's why I'm going to put that little times 2. The ends we're only leaving as multiplying by 1 itself. Okay, so I'm going to go ahead and use this formula and plug in. So I have my area is approximately my b minus a. Well, my b is 2, my a is 0. Again, that's my beginning and end points. And I'm going to divide that by 2 times how many trapezoids I have. That's my n. So I'll multiply by that by 4. And then I'm going to multiply by my y coordinates. So my first y coordinate is 0. I only want one of those. And then I'm going to double the interior y coordinates, again, because my trapezoid bases are doubled. So I'm going to double 1/8. I'm going to double 1. I'll move down here. I'm going to double 27/4. And finally, I'm going to just the single, I'm going to use 8. So I kind of ran out of room, so this part right here, if you want to look at it, is finishing up down there. So my area is approximately, well, 2 times 0 is 2, and then, so that leaves me with a fourth. And my 2's are going to cancel, so I'll have 2 over 8, which is 1/4. And then I'm going to simplify the interior. So I have a quarter plus 2 plus 20, let me see here. Oops, I messed up on this guy right here. Let me erase. This is supposed to be 27/8. Did I mess it up over here? Yeah, I did. Sorry, I didn't cube it, I squared it. This is supposed to be 1/8. Sorry about that, guys. Oops, that's not my eraser. There's my eraser. Alright, so then I'm going to have 27/4. And then finally plus 8. So let me double check to make sure I have all my pieces. Alright, looks good. So my area is approximately a quarter times, I'm going to put these two together, so that gives me 27 over 4 plus 1/4 gives me 28 over 4, which is 7. So I have 7 plus 2 plus 8. So it looks like I have a quarter. So 1/4 times looks like 17. So my area is approximately 17 over 4. Alright, number 2, function f is continuous on the interval from 2 to 8, has values in the given interval below using the sub-intervals of 2 to 5, 5 to 7, and 7 to 8. What is a trapezoidal approximation? And so on this case, we're going to talk about how do we do this with whereby heights are changing. So you probably noticed that I kind of delete this, but the height for this trapezoid is 3. The height for this trapezoid is going to be 2. The height of this trapezoid is going to be 1. And so we're going to have to just we're going to have to sum up all the areas of the individual trapezoids. And so my area is going to be approximately, so I'm going to do 3, that's my height, times the average of my y coordinate. So I'm averaging 30 plus 10. And I'm going to add that to the next part of my next trapezoid. So now I'm looking at 30 and 40. So I'm going to take the height, which is 2, and I'm going to multiply it by the average of my other two y coordinates, 30 and 40. And then finally, I'm going to add the height, which is 1. And then I'm going to average my last two y coordinates, which are 40 and 20. And so this is approximately 3 times 40 plus 10, that'll be 40, this will be 20, plus 2 times, looks like 35, plus 1 times 30. So this is approximately, let's be 60 plus 70 plus 30, and so my approximate area is 160.